7.1b. Finding roots or zeros and changing to standard form. All right, you ready? Number 1. What do you notice about this?
It's squared.
It's squared. Yes, I'm glad you noticed that. Is there anything else you notice about this? It's already factored. So if it's already factored, that saves me some time, right? It's pretty easy to get my answers if it's already factored. But I have a question before we get our answers. First off, what is the degree of this polynomial going to be? There's an x here, but because of this, doesn't this technically mean we have x minus 4, 2x plus 3, and then another 2x plus 3? Isn't that what that means? The squared means it's twice. So what degree, how many x's do we have?
3.
So how many zeros are we going to have?
3.
Okay, so 3 root zeros, solutions, etc. Okay, so I have 2 sets of instructions. One set of instruction is find the zeros, roots, whatever you want to call it. The second set of instructions is rewrite in standard form. So we're going to start off with finding the roots. How do I find the roots if it's already in this form? What we did yesterday. Set each of the parentheses equal to 0. Now, here's a question. If I have 2 parentheses that are exactly the same, do I need to show the work for both parentheses? Because the work's going to be exactly the same, right? That would be a waste of time. So let me get this one really quick. Add 4. So one of my answers is 4. Over here, I would subtract 3. 2x equals negative 3. Divide by 2, x equals negative 3 over 2. Now this is only 2 answers, and I needed 3. But remember, this actually comes from 2 separate parentheses. So how do I say that this is the answer twice? No, you don't want to square it, because squaring it would make it 9/4, and we don't want to go there. That's a different number, right? There's a couple different ways we can do it. I think our book tends to say this has a multiplicity of 2, meaning that it counts as 2 of the roots. Sometimes you might hear it called a double root, but you note that it has a multiplicity of 2, or that it's a double root, in order to get your 3 answers. Okay? And that's not just doing some magic to get your 3 answers. A multiplicity of 2 looks different when we graph it than something that has a multiplicity of 1. Okay, so it does have a different meaning on the graph. Questions there? Okay. So my next part says rewrite in standard form. So if I start here, where I have my x minus 4, 2x plus 3, 2x plus 3 equals 0, rewriting this in standard form involves what? Multiplying. Now, how do you multiply 3 parentheses? Well, you can't multiply 3 things at once. You can only ever multiply 2 things at once. So we're going to start off multiplying these 2, and then we'll take that answer and multiply it by that 3rd parentheses. Okay, so let's see. I have 2x squared plus 3x minus 8x minus 12. I'm going to go ahead and combine my like terms here. So I have 2x squared minus 5x minus 12. You okay with that? Leave that answer in parentheses and now bring down that other set of parentheses that we haven't touched yet. And we still have our equals 0. And at this point I multiply here, and then as long as I'm in standard form I should be done. So let's see, 2x squared times 2x, that would be 4x cubed. That's good, because didn't we say up above that it was a degree 3? So there's my cubed. 2x squared times 3, 6x squared. Negative 5x times 2x would be negative 10x squared. And negative 5x times 3 is negative 15x. Negative 12 times 2x is negative 24x. And negative 12 times 3 is negative 36. So let's see what I've got. I've got 4x cubed minus 4x squared minus 39x minus 36 equals 0. There we are in standard form. So two different parts of the question. Find your zeros, rewrite in standard form. Neither part should be very difficult. Yeah? Okay, next example. Okay, first thing I want to know is what's the degree? Any guesses? How many are here?
2.
How many are here?
2.
How many are there? 2 and 2 and 1 is?
5.
So in other words, when I multiply it out in standard form, I'm going to have x to the 5th as my leading term. Okay? That also means I have 5 roots total. Okay? So let's start off with the find the roots part. So I'm going to start off, remember outside this was the question on the homework. The homework was you had a 5 outside and you were wondering, do I get an answer from there? Do I not get an answer from there? If there's an x with it, there's an answer with it. And in fact, if there's an x squared there, there's 2 answers with it. So if I set x squared equal to 0, I solve it by square rooting, correct? That gives me x equals plus or minus, because when we take a square root, we always have to do plus or minus. What's the square root of 0?
0.
Now, does it make sense to say plus or minus 0?
No.
Makes no sense whatsoever. So I'm going to say x equals 0, but we have a multiplicity of 2. So that's 2 of my 5 answers. So? Next one, let's look at the next parentheses. X squared minus 2, set that equal to 0. We had one very similar to this yesterday, right? Add 2, and I get x squared equals 2. Square root both sides, remembering to put what? Plus and minus. So I have plus and minus radical 2. Do I put multiplicity of 2 there? No, because these are 2 different numbers. Positive radical 2 is a different number than negative radical 2. If you think about it on a number line, one's to the left of 0, one's to the right of 0. It's 2 different numbers. So this is already 2 answers on its own. So I have 4 answers. My last answer comes from 3x minus 5. Oops, didn't need a parentheses there. So I'm going to add 5. 3x equals 5. and x equals 5/3. Again, leave it as a fraction as long as you reduce it. Easy peasy? When it's already factored for you, it's pretty simple, right? And yesterday I talked about what these are going to represent once we get to graphing. Do you remember what these are going to represent? X-intercepts when we get to graphing. Okay? So now let's rewrite in standard form. So I'm going to write my equation again, x squared, and then x squared minus 2, 3x minus 5. Now, when we have something out front, people sometimes get confused of, do I distribute this through the parentheses, like the first set of parentheses, or through both sets of parentheses? Just the first one. I want you to think of, this might not be a good example, but if you've ever seen one of those things where they have like a bunch of champagne glasses stacked up in a pyramid, have you seen that? And then they pour in the top one, and what happens? It trickles down to all the others. If you distribute to the first parentheses, then when you multiply that result by the second one, that's the trickle down. It's going to naturally multiply through that one because you've already included it in the problem. So you don't want to start off by multiplying by all four, just by the first two. So let's see. If I multiply here, I have x to the fourth minus 2x squared. Put that in parentheses and now multiply by this guy. Because here's the trickle down. The x squared's hiding in this first parentheses. So x to the fourth times 3x gives me 3x to the fifth. That's good, isn't it? Because I said it was a degree 5 up there. X to the fourth times negative 5 is negative 5x to the fourth. Negative 2x squared times 3x is negative 6x cubed. Negative 2x times negative 5 is positive 10x squared. And double check to make sure you're in standard form. We're good. So? Okay. Let's see. The next one we're going to do, we're not going to do the rewrite in standard form part because I don't think you need more practice on that. But we are going to find the roots and talk about the degree. Okay? So, are you ready? We're trying to give you an exaggerated one just to prove the point. So yes, this one is a bit ridiculous, but the whole reason we gave it to you was to prove that you can find the degree of something without having to multiply it all out. What would you think the degree would be here? Let's see. I have x, but I have 3 of them, so that's a 3, right? So 3. How many do I have here? 5. How many here?
2.
And then another 2. So 3 and 5 are 8, 9, 10, 11, 12. So I have a 12th degree, which means there will be 12 answers. So? What answer do I get from here? Please tell me I don't need to show the work for that. Right? X equals positive 10 with a multiplicity of 3. Right? Because technically there's 3 parentheses that all look like that. What am I going to get from here? Negative 3 with a multiplicity of what? 5. Okay. X plus 4 squared. What am I going to get there? X equals what? Negative 4 with a multiplicity of what?
2.
So how many of my 12 answers do I have so far? 3, 8, 9, 10. So I only have 2 more. So finally I have x squared plus 9. That one I'll do a little solving for. Subtract 9. X squared equals negative 9. Uh-oh. What's going on here? So I have positive and negative. What's the square root of negative 9? 3i, right? Because the square root of 9 is 3. You can have imaginary roots. The imaginary roots will not show up like x-intercepts. They'll look a little different on our graphs. So? Okay. The last thing I want to show you, you don't necessarily need to write it down unless you want to. But all I want to do is I want to write down 2 equations, and I want you to tell me the degree and therefore the number of roots. Okay? So here we go. We're not actually going to find the roots, but 2.5x minus 7 to the 10th equals 0. What is my degree?
14.
I hear 14. So I have 3 here, and then another one makes 4, and then 10 here makes,
14.
so you would expect to find 14 answers there, which seems overwhelming, 14 answers, but if you look at one of them having a multiplicity of 10, that knocks out a lot of them real quick, right? All right, last one, same question. X to the third minus 2, 3x minus 5, 56x plus 1 equals 0. What is my degree? And therefore my number of roots. What have we got? 7, 8, 9, 10, 11, 12. Therefore you would find 12 answers. Okay, get the idea? All right, your homework is on Google Classroom. Happy studying.